slides. So I'm generating a sphere, which appears to be located at okay, here the sphere is oriented at the origin, and then I'm adding the points to it, scaling it. So it's located at 443. Oh, I see. There's a function here, camera object, given a camera parameter, which is, it's a structure. It has camera.pos, which is the camera position, camera.target, and basically that function is responsible for drawing the camera, all right, drawing that little pyramid with the point in there. So that's what's doing that. We have another function, camera plot. So what that does is it takes a point in space, okay, projects it to the camera location, and then gives it a color. That's being done right there. So the epipolar points is we take the camera 2 position and we calculate where it is in camera 1. That's the line where the cursor is at. And then the second one is we take the camera 1 position and find out where the points are in camera 2. Okay, I see what's going on here. We can only plot things in the world, right? So if you take a camera there's a camera. Take a point here. I can calculate what the point is where it hits the image plane. I can calculate that in camera coordinates. But in order to plot that point, on a 3D plot, I need to know what that point is in world coordinates, right? So the second argument is, first argument is where this point is in image coordinates. And the second point is where this point is in world coordinates. And then I use the world coordinates to actually construct it on the screen. Okay. So here we're drawing a line from the object position. We're drawing k different objects. So here we're drawing a line from the object position to where it intersects the camera in world coordinates. That's the x. We're doing the same thing in y, the same thing in z, because this is a plot 3. All right? So that's drawing that little segment in a particular color, and then I have a group of those segments I'm drawing, right, from the object to the camera, from the camera center to the other camera center, and that's going on there. It is possible to have a situation in which you cannot find the epipolar line. That's going to happen if, say, one camera is behind the other camera, right? Because now you can't see the image of this, the one camera can't see the center of the other camera, right? So situations in which the epipolar line isn't there. In order to see the epipolar lines, the cameras have to be reasonably positioned. Okay. What are we doing here? We're playing with the back projection. Here we are. So here's the, whoops, let me make this bigger. Here's the actual position of the point, 483 for this script. Okay? And then we busily calculate where it hits camera position, here's the camera data. So we take the camera data and we do our back projection code, and we come out with the 483. And we remember that the two lines may not intersect perfectly, I mean in the real world, right? So here I'm calculating the distance that the lines are apart, right? And the answer is they're not, it's the same point. Okay, here we have a number of cameras. I don't see, there they are plotted. So I'm trying to extract the positions. I'm not sure why that matrix is singular. Principal point 0, 0, no skew, focal length 1, 1, no distortion, no tangential distortion. Here's the reprojection error. Take a look at the power of 10 up there. So those corners are where they are reprojected, where they're supposed to be, to 10 to the minus 16th. So effectively perfect. I don't know why that's in there at the moment. Just testing the routines. Okay, so that's actually stereo, right? Two cameras, but you got to know where the cameras are, right? All of that stuff about the cameras is known ahead of time when we're doing this. Ah, too far. Okay, so we took some artificial images. Okay. And we appeared to be running the MATLAB camera calibrator here. Although it doesn't look like I actually showed the calibration parameters. calibrating camera 2. Now we're looking at the two scenes side by side. One seen by one camera, the other one seen by the other camera. Not sure what that's doing. Just generating more artificial images. Okay, so here we're starting to identify features, right, that are in both of the images. I guess I'm looking at the values. I haven't looked at these for a while. Oh, I see where we're going next. And we don't want to go there with 5 minutes left in the period, so we're going to call it right there. So, hopefully, homework assignment. Is there a big issue with it, or it's just a matter of, takes time? All right, I will delay posting, or have I already posted the next assignment? I'll delay that a little bit.